Hello, my name is Daniel Stepp, and this is my lab 2 on motion and throwing an object. So the purpose of this lab was to test the motion of a falling object and to simulate it and to compare the simulation to the actual data that we calculated from a video of us throwing an object. We use a lot of models and principles in physics ideas in this lab. Most importantly, we use Newton's second law, which is force equals mass times acceleration. We can use this formula to and expand it and show a lot of things and use it to find a velocity update formula or a position update formula, um, which is important in trying to simulate where a object will be and predicting its position at certain times. We also use the idea of Fnet. In this case, the only forces acting on the object once the object was thrown was drag and gravity. The drag equation is listed in the top right. It's another idea that we used. That the force of drag equals negative b, which is some constant, times the velocity squared times the direction of the velocity. And so that went with our Fnet equation as well. These were the ideas that we used in this physics lab 2. So here are results. This is the final coding thing that I found. We were able to effectively compare the data of the thrown projectile to the actual video of the thrown projectile. And I'll be able to show that later on as well. So the system of this lab, the system was the paper ball that we threw, and the surroundings would typically just be everything around it, including like the air resistance that has a force on the ball, and gravity, the earth pulling it down. So the initial conditions that we had was that we threw the ball with an initial speed or an initial velocity in the x and y direction. And then after that was really the only initial condition. The ball was in the air, and then just have been released from one of our lab mates' hands, and then was in the air under just the effect of gravity and drag. Yeah. So the process, how we conducted this experiment, we wadded up the paper ball. There's a couple pieces of paper, and measured a meter stick and released the ball from the top of the meter, or like from the top of the meter stick, and with an initial speed. And then we used the tracker data to figure out how fast the ball had been moving, what its speed was, and what its trajectory was. And we made sure to stop the video right as soon as the ball hit the ground, or I guess like right before it hits the ground, because so that way it's not the paper ball is not exerted on, or does not have another force exerting on it. And then we graphed it into the lab flow to make it look like this. This is our data versus simulation. We simulated the data on lab flow and got what we have on the right or on the left. And then on the right is our tracker data that we found just by plotting the graph. And so as you can see, they're very similar, but I'll go into the differences in a minute. So we also coded a lot in this lab. This is some of the code that we made, mainly just using the Fnet equation, which was the gravity plus drag. We just found our drag constant ended up being pretty low, but yeah. And then our gravity constant or gravity force was just the ball, like just the mass times the force of gravity. And the mass of the object was around 10 grams, which is shown in our code. So this object did not reach terminal velocity. As you can see, the trajectory is constantly increasing in speed, so it has not reached a constant speed or a max speed. And then also, if it was thrown up straight up with the same speed, it would reach the ground later, because some of that x speed would be transferred into y speed, which would make it spend more time in the air before gravity could bring it back down. And thank you for watching.